concept in a heat transfer, convection heat transfer analysis is boundary layer, right? It's very important. Partly, you might have seen this in fluid mechanics as well, isn't it? Boundary layers, or boundary layers are formed. Listen here carefully. Let us take a case that we all know or see quite often. Water is flowing in a canal, and the bottommost material that is in the canal or river is, let's say, sand bed, in a typical river that you may see. And imagine the water is flowing there smoothly, and that water is flowing, right? Even though it appears like one single mass that is flowing, we can imagine that to be flowing in a very smooth or tranquil condition, wherein you can imagine the water to have split itself into number of multiple layers, and one is floating over the other. How it happens? So just see this. The bottommost surface, this is the sand bed, right? Over which the fluid, which in this case is water, is flowing, right? Now imagine the water is flowing like this. This is the first layer over the sand bed. Next, second layer, third layer, fourth layer, and so on. Now you tell me whether the speed with which this is flowing is same as the speed with which the other layer is flowing. Is it same or different? Huh? The speed with which any particle in this layer is moving, and the speed any particle in this layer, and the speed, will it be same in all the cases, or will it be different? It will be different. So now let me take as this is, say, first layer, and this is fourth layer. Velocity of first layer is u1, and velocity of the fourth layer is u4. Which will be more? U4? Right? So u4 is greater than u1. Why? What is the reason? You are correct. What is the reason? Right? What is the reason? So the reason is simple, right? The resistance offered by the surface over which it is flowing. There is something called as no slip condition. The bottommost layer, in fact, sticks to the surface because it is very rough, right? And theoretically, the first layer that is coming in contact with this surface will have a zero velocity. Theoretically, I can say it tends to be zero, if not equal to zero. It's almost zero. And as you move up, the velocity increases. So the top layer that you see from outside is moving at the fastest rate. Now, what is the effect of this? Right now, you can put it like this: there is some force which is opposing the motion of the fluid. There is some resistance. You call it as friction, to put it in simpler terms. But because fluid is involved here, we call it as viscous effect. Because viscosity plays here bigger role. Let's imagine in the same river, instead of water, oil is flowing, say castor oil. Right? Will the velocity be different or not? It will be, because oil has more viscosity. Therefore, its tendency to move comes down. It will become little more slower. Right? So therefore, you need to understand that there is some force which is opposing the motion of this fluid, and that force will be maximum at this point, right? And that force decreases, intensity of that opposing force decreases as you move up. Right? That is one point. And the second point, there is something called as shear stress. You all know, right? When one layer is moving the other, the layer which is moving, right, slowly, will try to reduce the velocity of the other layer. Retards, tries to retard. And the layer which is moving at higher speed will try to, increase the velocity of the other one which is going slow. It is something like, right? Two people are, traveling, and one is holding the hand of the other. One has the ability, natural ability to walk fast. Another has, ability not so, good at walking fast. But because both are tied down, the tendency of the person who is walking slow is like he is getting pull effect. Whatever his original capability plus something is there, right? So he is gaining something. Now the person who is capable of walking fast, what is the effect? He is actually slowed down because he has to pull him, and the faster person is slowing down, and the slower person is getting speeded up. The same thing happens, right? Because now each of these layer is dependent on the other, because as such there is no gap as we are seeing here. One is in surface contact with the other. So therefore, now you see the diagram. At the bottommost point, the velocity is 0. Now, say it is taken to some scale. Now what is shown here? U infinity is shown like this. That means this width of this line, say 1 centimeter, is equal to, say, 10 meter per second, right? Scale is taken approximately 1 centimeter. You know, on the drawing chart you do this, is equal to 10 meter per second. Arbitrarily I am taking this value. What is this 10 meters? This is U infinity. Now therefore if the width becomes half centimeters, then this becomes 5 meter per second. If this width becomes 0, then what is the velocity? 0 meter per second. Now at this point, is there any width? It's a point. So therefore what is the velocity here? Velocity is 0. As you go up slowly, what is happening? The effect of opposing force is decreasing, and hence the velocity is increasing. After certain point, the velocity will become equal to the original or initial velocity, which we call it as free stream velocity. The U infinity is called free stream velocity. Free stream velocity. Similarly, if there is temperature T infinity, we call it as free stream temperature. Right? So, gradually the velocity is increasing. At certain point it becomes equal to the initial velocity, which we are calling. Why it is called free stream velocity? It is not influenced by this plate. It is not touching this. It is external, right? It is traveling on its own. But now once entering this environment or zone, it is affected by these viscous effects or opposing forces, right? And now here if you go a little deeper, you can also understand, right? So this, suppose if the shear stress is tau, shear stress, what is the equation in terms of viscosity? Mu into du by dy, where mu is the viscosity, du by dy is velocity gradient in the direction of y. Y is in the vertical direction, x is in the horizontal direction. So there is a kind of shear force exerted by one layer on the other layer. So now the point beyond which the velocity is u infinity means that the effect of this viscosity or whatever the conditions that prevail over the plate is nullified now. Beyond this point, there is no effect of this surface, right? So it is penetrated up to this point. See, it is something like that, right? There is no fan here again in plate, the same case. If you are very closer to the fan, you are getting influenced by, or at least you are feeling the velocity of the air or fluid motion around it. If you keep away from it, there is a point where you can't feel the effect of it at all. Are you getting me? So likewise, here there is maximum effect. As you moving away from it, you are least affected. See, we use this in our day-to-day terms, right? Dushtuni duranga undandi antaru. If there is a bad friend, keep away from him. If there is a bad element, keep away from them. See the same meaning here. No, you are not actually influenced by that person or thing or effect. So now the distance between this point and that point beyond which you are not feeling the effect of this is called boundary layer thickness, denoted by delta. That is the physical meaning of the boundary layer thickness, delta. And this is called velocity boundary layer, or another name to this is hydrodynamic boundary layer. Velocity or hydrodynamic boundary layer. Right? Please make it. Another observation you should have made is this curve. What is this? This is, the curve which connects all the points whose distance from the original surface is delta. And this delta is not constant throughout the length of the plane. At the beginning, the delta is very small, and as you move deeper along the length in x direction, this is increased. Why? Again, our common sense can understand this. Here at the beginning, the effect is naturally less. See, it's like, if you are closer to a bad friend, initially you may not notice his influence on you. Maybe in 1 day or 1 hour, you cannot recognize, right? Maybe the longer the time you are with him, say for 1 semester or 1 year, the chances that you pick up his qualities are more, because your bonding gets strengthened. Right? That means you are giving that effect enough time, right, to have on you. So here, as this is moving along, so the more and more time is allowed. So therefore, the effect is increasing. The effect of this boundary or surface condition is increasing. It's minimal or zero here because it's just entering. Good or bad friend, first day, right? You will hardly feel that. Is it? So 1 day pass, 2 days, 3 days, month, and then it is continuously increasing. So that is the meaning of this. So at each of these points you measure delta and you connect all those points, connect the dots. Then that is the boundary layer. See here what is shown here, delta as a function of x. That means delta depends on x. And in this case it is increasing. Right? That is another point you should note down. I think it must be reflected from somewhere here. Otherwise you should